Hello, everyone. Welcome to Bay Coding Club webinar with Andi Qu, who is the championship of the USACO IOI. And he right now is the student at MIT in major computer science. And before he do the presentation, let me introduce a little bit about Bay Coding Club. So Bay Coding Lab is a K-12 technology and mathematics academy at Bay Area, California. And we provide cutting edge of computer science education and at the same time the mathematics for K-12. We offer different kind of computer science club also. And our team, including some of senior technology engineers and some of our professors from different kind of universities. Right now, we provide only in the language in English. We teach in English. We don't have any Chinese class, but in the future, I believe we're gonna have the Chinese class. This is a little bit roadmap of our development for Bay Coding Club. We established in 2015 as a nonprofit at upstate New York. And we moved to California in 2009. We opened online classes in 2020. A little bit about me. I am a community teacher for computer basic for our kids, and I'm two of the company's founder before. I owned a software company and also a public relations company in Beijing many years ago. And I established the Bay Coding Club like 5 years ago. And I'm a mom with a 10-year-old daughter. Okay. This is some of our courses online. We have a dynamic of a course. Of course, we provide a lot of courses according to kids' interest. We do give the kids evaluation before you register on our course. We also ask you to do an evaluation, including we want to ask you what the purpose you want to learn computer science, what the purpose you want to go with us, and what your hobby is, what's your interest. Do you like computer science or do you like game design? Whatever you want to participate in the competition courses or whatever. So we made a lot of unique pathways for you. If you okay, this is the roadmap of us. And this is a little bit about me. This is our class. Okay. And this is some of our class. I just did the very snapshot from our website. And this is a part our galleries from our website. So I believe you can get a lot of information if you want. You can log on our website at baycodingclub.com. Okay, this is introduction for short for our school. And I will just warmly welcome our speaker, Andi Qu, and let him introduce himself again. Andi?
I'm going to share my screen now.
Yes, I think you can right now. Can you share? Can you share your screen?
I'm sharing. Can everyone see?
I believe you can right now because you're a co-host.
Yeah, I am. Yeah, as Ruby said, I'm Andy, and I'm going to be. And so, be talking a bit about IOI. So in case you don't know, I represented South Africa from 2019, which was in Azerbaijan, to 2021, which is this year. So yeah, firstly, what is IOI? Well, it stands for the International Olympiad in Informatics. And so it's basically a big programming competition. So it's the most prestigious programming contest for high school students. And so countries from all over the world send students to compete. Generally, each country sends 4 contestants. And I think there were something like 70 or 80 countries competing this year. And so how the medals work is the top 50% of the contestants get a medal. And out of those top 50% of the contestants, the ratio of gold, silver, and bronze is 1 to 2 to 3. So yeah, getting a gold medal means that you have to be in the top 12 of all contestants. So like these are some of the best programmers in the world in high school. And then to get silver, you have to be in the next 1/6. To get a bronze, you have to be in the next quarter of contestants. Okay, so now that you know what IOI is, let's talk a bit about how a contest is structured. So basically, you get 5 hours to solve 3 problems generally. Some years, such as 2009 and 2010, had 4 problems, and they're not ordered in difficulty. And you basically have to write a program to solve each problem. And just to make it a bit easier for the contestants, each problem has subtasks. So a subtask is basically an easier version of the original problem so that you can get partial points. So for example, if the problem is something like sort a list of 1,000,000 numbers, then a subtask could be sort a list of 10 numbers, which is much easier to do. One thing that I forgot to include in this slide is that the contest
it's a little bit cut off. It's getting better. Is it from my side or Andy's side, Rachel?
It's on Andy's side.
Okay, Andy, there's a little bit cut off. I believe the Wi-Fi is not stable at your side.
Sorry. It just fine. Better now.
Yeah, I think we can hear you right now, but the camera was a little bit blurb that we cannot. You want to adjust a little bit? No worries. Yeah.
It's fine. Okay.
All right.
So yeah, usually to get like a bronze medal, you need 300 points out of 600. To get a silver, you need like 400-ish points to get. You usually need about 500 points, which is all. So yeah, do you think it's only just 3 problems? Sorry. Okay. So yeah, does it sound easy? Okay. So here's an example question from the IOI. This is from 2017. So basically you have some books numbered 0 to N. So it's 3. And basically you can only hold one book at a time, and you start at one of the books and you just want to sort them, but you don't want to walk, so you want to find the minimum distance you need to sort the books. And so while this may sound really simple and quite easy, it's actually not, because N can be really large. So you could be sorting 1 million books, and you can't just try out each possible combination, because you have to write a program to solve it in less than 2 seconds. So if you just check each possible thing, then that will take too long and you won't be able to solve the problem quickly. And it has to work on all possible book configurations. It can't just work on a specific example. So it can't just be for like this picture here. It has to work for all possible things. Like even if the guy started on table 2, your program has to work. So yeah, I think only 27 people solved this problem out of about 350. So that should give you an idea of how difficult these problems can get. Okay, so yeah, here's basically how to get to the IOI. So there are kind of 4 main stages. So first you learn to code, next you compete in the local Olympiads, then you go to team selection camps, and then finally you compete in the IOI. So I will go through each of these 4 steps in my presentation now. So first, you have to learn how to code, of course. So one of the main things that people consider when learning how to code is which programming language to use. So in programming Olympiads, there are usually 4 main languages that people learn and use, because these languages are very popular in real life as well. So for instance, Java was used to write Minecraft. So these 4 are Python, Java, C++, and Pascal. Although Pascal is a very old programming language, so very few people use it these days. And actually, most programming Olympiads don't allow you to submit code written in Pascal anymore. So yeah, if you want to try out programming Olympiads, then you should try these 3 languages. So Python is probably the language that most people first learn, because it's quite simple and easy to learn. A lot of people say it's like coding in English because of how the code looks. So there aren't a lot of complicated things. And another nice thing is that some programming Olympiads, such as the USACO, allow you to submit in Python. So the downsides of Python are, firstly, it's quite slow. So if the task needs you to write a program to solve it in less than 2 seconds, then if you use C++, they'll be like quite easy, because C++ is very fast. But if you use Python, it'll be a lot harder, because Python is quite slow. And another downside of Python is that a lot of programming Olympiads actually don't allow you to submit code in Python because it's so slow. So for example, the IOI actually doesn't allow you to submit in Python So most people just learn it as the first language and then transition over to either Java or C++. So the next language that's used quite a lot is Java. And Java is nice because it's used.
I believe Andy's said it.
Such as Minecraft were written in it. And another good thing about Java is that you usually learn it in school. So in high school, if you take APCS, then you'll probably learn Java. And so that's also another good choice. So the main downside of Java is that a lot of programming Olympiads actually don't allow you to submit in Java. So up until 2020, the IOI allowed Java, but then in 2021 and in 2020, they don't allow you to submit using Java anymore. It's only C++. So finally, we have C++, which is what actually everyone at the IOI uses, that have to use. So the reason why C++ is because it's very fast. So if you write, it will probably run in like under a second if you. And another reason why C++ is nice is because it has the standard template library, so the STL, and it is nice because it has a lot of things that are implemented. So a lot of data structures and algorithms that you don't need to implement from scratch because it's built into the language. And so that's a very popular choice for competitive programming. But the main downside of C++ is that it's very, very difficult. I actually don't recommend you learn C++ as your first language because you will probably get frustrated by it and you might give up because it's very unintuitive and not really nice as a first language. So if you just wanted to start out programming, I'd highly suggest either Python, because those are much nicer. They're also more modern languages. You'll find that more people actually know how to program in Python and Java than in C++. And Pascal is just very old. I actually don't know much about it at all. But that being said, language that you learn actually isn't really important because your language, it's usually quite easy to switch over to if it's completely different, because all the concepts are signals and loops and so on. Main thing you need to focus on when learning a language is how you can use that language to solve problems. So priority queue is in C++, how to use its properties to kind of help you solve difficult problems. If you're learning how to code, that's another thing. I think you should try. So where can you learn programming languages? Well, there are a bunch of different places. So for example, in school, so APCS, You can learn it online, which is what most people do, I think. So you can just Google something like Python tutorial and there'll be like 500 that pop up, and you can just click the top result and it should be good enough. You can learn it from books. So this is quite an old-fashioned way, but some people do it. Like for instance, C++ has a book that has everything you need to know about it, although learning it this way is a bit slower. And finally, a lot of people learn how to program just by playing around with code on their computer and seeing what happens. So this is also quite slow, but it's quite fun if you like just want to mess around and you don't really have a specific goal in mind. You just want to create something. Okay, so that covers the first step to IOI. The next part is participating in local Olympiads. And by local, I mean like national or statewide Olympiads. So each country has their own different one. So each country's structure may be a bit different, but in general, this is how they work. So generally, they're either a regional or national competition. And if it's popular enough, such as the USACO, then you can also participate online, even if you're not from that country. So like USA does it, Japan does it, Croatia does it, and so on. So these Olympiads are usually easier than the IOI because one of the main purposes is to get kids to get interested in computer science. So if it's too difficult, they'll just scare them away, which isn't good. And also it's kind of a form of team selection. So it has to be a bit easier than IOI so that people don't just get 0 and then they can't choose the team. And yeah, as I said before, it's usually to encourage students to learn computer science. And because of that, you'll find that a lot of them are registered through schools, or like CS teachers will encourage the students to do these Olympiads. So some examples of big national Olympiads are the USA Computing Olympiad, which is USACO. And how this works is there are 4 competitions. So one for each month from December to March. And the March one is a big contest called the US Open. And it's 5 hours long, and each of the others is 4 hours long. So this is probably the biggest national Olympiad and one that most competitive programmers actually participate in. And so that's actually quite soon. So if you want to, you should check it out. Just go to usaco.org and then you can register. The next big one is the JOI, which is the Japanese Olympiad in informatics. So excluding the training camps, there are 2 contests. So there's the final round of the National Olympiad, which is held in April. And then there's the open contest, which is held in July. And so the open contest is open to everyone on the internet, not just like, and it's not used for team selection. It's just kind of like a fun contest. Japan also has regional contests. I think they have 2 before the final round, but those are usually closed to the public. There's the Polish Olympiad, which has 5 contests spread throughout the year. And there's the Croatian Olympiad, which has 9 contests spread throughout the year. So each of these Olympiads actually has an online mirror that anyone can compete in. And so you'll notice that in the previous slide, I said that the contests are usually easier than the IOI. And the reason why I said usually and not always is because actually USACO and JOI are generally harder than the IOI because Japan and USA are strong countries. So they want their local contests to be as difficult as possible, in reason, of course. So to get involved in these competitions, usually you sign up through a school or something, but in the case of the US, you just go to usaco.org and you register there and you're all set. So it's like an independent thing. You don't need a school to sign up for you. But for most other countries or contests, you register through your school, and in some cases, if there's an online mirror, you register online. So for example, this is the Central European Olympiad in Informatics in 2021, and as you can see here, there was an online contest and you could have registered and competed, which is quite cool. So yeah, usually people start these contests in high school. So by that, I mean like 8th grade, 9th grade. But some people do start a bit earlier, such as middle school. I don't recommend this though, because before high school, you should be kind of just having a bit more fun. You shouldn't really be doing these big intense contests. And you should also just be kind of learning to code. But if you already know how to code and you're in middle school and you're confident in your abilities, then go for it if you want to. It's a great opportunity and it's really fun if you do well in it. So yeah, that's it for local Olympiads. And so if you perform well enough in those, so for instance, in USACO, if you're in the platinum division and you consistently perform in like the top 20 of high school contestants from the USA, then you'll get invited to team selection camps. And so these camps are just camps where they choose the final team for the IOI. And these generally happen in around like March or April, so that the team can train for the actual big contest. So how they work is, well, each country has their own process, so it's different for each country, but in general, it's a training camp where they hold contests in the morning to kind of see who out of all the people in that camp are the best at competitive programming. And then from those results, they select the teams. And usually there are also multiple camps and multiple stages. So like the first camp might have a lot of people and then they eliminate some of them and then it gets smaller and smaller until the final camp. But for some countries like the USA, there's only one camp and from there they choose the team and that's it. So another part of team selection camps is actually participating in other international contests. So by international, I mean a few countries that just get together. It's not like all the countries of the world get together and hold a contest. So these contests are slightly above local Olympiads, but still generally easier than the IOI. So yeah, some examples of these are the Baltic Olympiad in Informatics, which is like Estonia, Germany, Sweden, Ukraine, I think, and so on. There's the Balkan Olympiad, which hasn't happened for the past 2 years because of the pandemic. But generally, it's countries in the Balkans like Macedonia, Romania, Moldova, and so on. There's the Central European Olympiad, which we saw earlier. So that's like Central Europe, and it's like countries like Croatia, Hungary, Israel for some reason, and so on. Asia Pacific, which is kind of like the one exception to the easier than IOI rule, because APIO is done by a lot of Asian countries like Japan, China, Iran, and so on, which are very strong countries. So their problems are generally like harder than IOI problems, and so on. So yeah, this is the Baltic Olympiad. It was held in Germany. APIO was held in Indonesia this year, and CEOI was held in Croatia. So yeah, basically these are shorter contests. So instead of 2 days like the IOI, generally they're 1 day contests, so there are only 3 problems instead of 6. And yeah, so yeah, some countries also use these contests for team selection, but other countries just do them for fun. So I think like China doesn't use this for team selection, and Japan also doesn't, because by the time that these contests happen, they've already chosen the teams. So yeah, that's kind of the process for team selection. These camps usually run for about 4 days. So 4 days of competition. Sometimes there may be breaks in between, just so that the campers can kind of recover, because these contests are very draining. It takes a lot of stamina to sit through 5 hours of just thinking about programming. Each day generally has 1 contest. Sometimes there are 2, but that's very rare. So in total, there's about 20 hours of competitions, all compressed in a week. So yeah, it's very intense. And yeah, so after that, if you do well enough, so if you place in the top 4 of people in your country, then you get selected for the team and you can go to the IOI. And yeah, so then it's just the home stretch, and you just compete, do as well as you can, and if you get a medal, you get a medal. But yeah, as I like to think, it's mostly just for the fun of it, because if you go to the IOI, then usually, well, not for the past 2 years, but usually you get to go to a different country. So like in 2017, you could go to Iran, and that was very fun because there were like a lot of cats on the street and stuff, and you can kind of walk around, see what it's like. 2018 was in Japan, which was also very cool. So yeah, each year a different country hosts it, and generally all the contestants go to that country to compete, which is really fun, and you get to meet a lot of cool people. And yeah, so that's basically it for the road. But you might be wondering about these triangles here. So what are these about? What happens in between these steps? Well, between those steps, obviously you need to practice. So by practice, I mean things like kind of reading up on the theory of stuff. So if you need to learn a new algorithm, then that's like practice. If you need to develop your contest strategy or improve your stamina, then that's practice. And so I like to think that this is actually the most important part of the process, because without it, you can't get from one stage to the next. So yeah, practice is everything. The way that you can learn how to solve a problem by looking at it instead of just throwing everything randomly at it is by practice. To get the stamina for 5-hour contests without like passing out or kind of not being able to think, you need practice. So you have to like do virtual contests just to get the feeling of what it's like to think constantly for 5 hours. To develop a good contest strategy, you also need practice. And so in general, to get good at anything, well, this holds for anything in life actually, you just need to practice constantly. And yeah, so the way you can practice for these Olympiads is there are actually quite a few ways. So the most popular way, I think, is just to solve problems from previous contests. So usually problems from past IOIs and local Olympiads are available online, and you can actually submit code and see if it's correct. And this is very popular because firstly, it's accessible. It's just online. You can search like, so if you remember the example IOI problem I was talking about, ancient books from 2017, you can just Google the name of that problem, and then there will be an online platform to submit your code and see if it's correct. Another nice thing about this way to practice is that the difficulty of past problems usually indicate how difficult future problems will be, and also the style. So if you kind of practice this way a lot, then you'll see that countries like Poland, Hungary, Croatia really like geometry problems. So if you're preparing for, say, the Balkan Olympiad or the Central European Olympiad, then you'd know that you can do well by practicing a lot of geometry. But if you try Japanese problems or Chinese problems, you'll see that they really like dynamic programming. So you can practice those problems. But that being said, I will note that problems from Olympiads have been getting much harder recently because simply because the competitors have just been getting better as time has gone on, because resources for practicing have become more accessible online, and because these Olympiads have also become more popular over time. So yeah, I highly recommend this way of practicing. And another nice thing about this is that you'll basically never run out of problems, because there are literally thousands of these kinds of problems that you can just look up and solve. And if it takes you like a day to solve one problem, it'll literally take you years, something like 10 years to solve every single problem. Okay, so yeah, another nice way to practice is by competing in online contests. So this is a bit less accessible than the previous one because these contests are live and you have to be awake and available when they happen. But fortunately, they happen quite often. So for instance, the most popular platform for online contests is Codeforces. And Codeforces generally has at least one contest every week. And it doesn't really matter which time zone you're in because they're always in different time zones, like they're at different times. AppCoder is also very nice because it has very high quality problems. Like Codeforces doesn't really have nice problems. It's like it doesn't feel very fun to solve them, but AppCoder is very good because it's a Japanese website. And yeah, so basically just find an online platform and compete in the contests. So this has a bunch of its own advantages as well. So firstly, it has more recent problems. So it's more indicative of the difficulty of like future problems. Because these ones aren't like from 20 years ago when computers really sucked. So these are modern problems that use modern techniques, and it shows you what's popular in the meta at the moment. So that's very nice, and it'll actually prepare you more for big contests like the IOI. It's also nice because it's an actual contest environment, so you're put under stress to perform, and so that'll make you get used to kind of the stress of competition. Whereas if you just solve problems casually from past contests, you have no pressure to kind of solve them as quickly as possible. And so when you get into an actual contest, you'll find that you might suffer a bit because you don't know what it's like to actually compete in a contest. And these contests are usually they're usually quite short as well. So I think usually they're 3 hours instead of 5. So yeah. And finally, you should just discuss programming with other people who are interested as well. So there are a lot of online forums for competitive programming, like on Discord, on Codeforces, on Facebook even. So yeah, this is nice because if you're stuck on something, so if you're stuck on a problem, then chances are that there will be someone online who has solved it before and they can kind of give you hints and help you. And that's very useful for when you want to learn new techniques that you might not know, or just creative applications of techniques that you already know. And if you discuss a lot with people who are better at programming than you, then you'll find that your skill also improves a lot because like you're just constantly learning new stuff. And this is also one of the reasons why going to the IOI is so fun, because you'll find that once you're there, there are always like 10 other people that are much better than you, and you can kind of like befriend them and learn new stuff from them, which is really cool. So yeah, ideally you should be discussing with people who are better than you, so who know more about a specific technique or something than you. But that's a bit intimidating sometimes, so you can also kind of just find a group of friends and discuss together, which makes it quite fun as well. So yeah, that's basically it for how to practice. And so yeah, that's pretty much it for my IOI journey. And if you can't follow these tips, then hopefully you'll also be able to get quite far in competitive programming, at least in USACO, like get to the platinum division or something. So yeah, does anyone have any questions for me?
Hey, Andy, yeah, before you open the question to the audience today, we do have some questions collected from our registration form. You
Yes.
would like to answer those questions first?
Yes, okay.
All right, yeah. Here has some parents ask, how old do you think the kids can prepare for the musical?
So I think you should like try learn to code as soon as possible, not just because it's useful for USACO, but because it's useful for real life in general. Like you'll be finding that you need to code a lot. But specifically for USACO, I think something like 8th grade or even later is a good time to start. But if you're already in high school and like you passed that time, don't worry, you can still get started. Like I only got started in USACO in 10th grade and I still did fine. So yeah, it's like how they say best time to start was 5 years ago, but the second best time to start is now.
Okay, so which language you recommend that 8th grader to learn at the beginning to get involved into the musical? Because I do notice that the C++ is the very fast if you use in musical, but normally like 8th grader, they're not quite get along or quite knowing about like Java. So do you recommend they first get started from Java and move to the C++? What do you think?
Yeah, basically just get started with either like Java or Python and then move over. So Java is actually really nice for a first language because if you learn it, then you'll also learn it in APCS. So if you take APCS in high school, then you'll also be doing Java, which is nice. So if you learn it early, then you'll have an easy time in that class.
Okay, here has the parents questions ask. So so get a registration by themselves. Do they need a team like a peers?
No,
Yeah.
they don't need a team at all. It's like totally an individual thing. And actually in these Olympiads, you can't collaborate with people. You have to just use your own thoughts. That being said, there are team contests. So a big one is Google Hashcode, which is a team, like one of the biggest team contests where you actually solve real world problems like image processing. So yeah.
Yeah. So when parents ask, how do you practice your musical?
I practice by solving past USACO problems. So actually, let me just share my other screen and show you. So, sorry. Let me just share my other screen. So if you go to the USACO website here, it's nice because you can go to contests and go to a previous contest. So as you can see here, there are a lot. So there's a lot to practice from. And you can go to like, say, 2021 Feb and go to a problem. And then, so this is the problem. And if you log in, you can submit code. And another nice thing about USACO is that if you don't know how to solve something, you can just go back and click solution and it tells you how to do it. And it even gives you code. So yeah.
Okay, I think I have enough questions from the registration form. So we would like to open the question answers for the audience here. So if you have any question, either from Zoom or from Clubhouse, you can just raise your hands up, or you just open your mic directly. Or from the Clubhouse, you can, raise up your hands, and then I will let you to speak. So anyone has any questions about the musical?
I see in the chat someone asked, should kids
Yeah, you
learn
also can do the chat.
Java
Yeah.
and C++, or like should they learn all of them? And I think no, they don't need to learn all of them. They only need to know one programming language really. But if they really want to, they can learn all of them. Like I know Python and C++, but not Java. Are there textbooks for kids programming? I actually don't know because I didn't learn from a book. But I'm sure if you search for a textbook online, so learn. So if you search that, then then there are a lot. So let me just share my screen again. So as you can see here, there are quite a lot of books. So I think this one is quite nice. I've seen it before.
Yeah. And Andy, don't forget our Coding Club book.
Yeah, Coding Club as well.
Yeah, we have a book for kids for Python and Java. What our book is different for other book is we have a lot of practice questions at the end of the book. So there's the questions and answers. Our Coding Club books for kids coding is different to other.
Yeah, that's
you
very.
can,
you need to have practice questions to improve. So that's also a very good resource.
Yeah, you also can log on our website to check out the book from Coding Club, or you can we sell our Coding Club book for kids coding at Amazon too. So you can log on Amazon and Google Coding Club book so you can see it. Yeah, thank you for answering this question. Does any other have any questions? Yeah.
So someone asked, are there C++ classes? No, I don't think there are yet.
We have a musical C++ class.
Okay.
Called by Matthew. Matthew was the gold at the gold medal of the musical. So we have a musical C++ classes is on. We have a team already over there. So for those of you who prepare for the musical, I highly recommend you learn some like Python, Java first. And and then you can just facing a lot of challenges at the musical. Also, you can also attend ACSL, and which we're in the process of registration right now. Okay, are there any question you can chat?
If your child has both Chinese and American passports and holds a Canadian permanent residency card, while he attends high school in the UK, which country can he represent? So if you have Chinese and American passports, you can represent both of those countries. I know that someone in the 2019 and 2020 team from the USA actually lives in Taiwan. So yeah, you can do that. I am not sure about Canada. I'm not sure how they do it there. And I think for the UK, well, for the IMO at least, you can represent them, because I know a Japanese girl who went to school in the UK and she represented them. Oh, not allowed in China. Oh, okay, yeah, my bad, sorry. But yeah, in the US, you are allowed if you have citizenship. So if you have a passport. Yeah, but not sure about Canada or the UK. Any other questions?
Any other questions? You can chat. Either you can open your mic and ask. Is there any question from Clubhouse? If you have, you can just raise your hands up, and then I will let you speak. All right, Andy, since you are the teacher of Bay Coding Club, so from your, I do have maybe 1 or 2 questions to ask you related with the musical. So so you said just now that is 8th grader could be better to prepare for the musical. So before 8th grade, what kind of language, or when do you think they be better to start it with their coding language learning?
Start it whenever you want to start, like whenever you feel ready.
You know, there's some sayings said there's a controversial that ask kids to learn coding because this some of the parents think they're too young to learn coding. So when do you think it's too when do you think it's too because kids are too young to learn coding? So what age or what grade do you recommend for kids to learn coding in your perspective?
I think as soon as possible, actually.
Mm-hmm.
You can actually start in 1st grade if you're taught right.
Yeah.
So like if you're taught badly, obviously you're not gonna like coding and you're not going to understand it. But like if you start early and you just taught the basics well, then you should be fine.
Yeah. So our Bay Coding Club philosophy is just, not only teach kids computer science, we want to combine with the creativities, art, design together with the computer science. And our opinion is the same. The younger, the better. Because with the age they goes, they have a lot of other tasks, such as they goes to the 8th grader, they will think about the community volunteer works, jobs a lot. So the sooner I think the better. Yeah, and I agree with Andy. It should be find their interest. Yeah, so get started from their interest. Okay, any other questions from Zoom, either from Clubhouse? You can open your mic and ask. Okay, it seems like nobody want to ask questions. All right, Andy. Okay, since nobody asked a question, do you have any takeaways for today as a recap here?
Okay, so yeah, basically, if you're interested in doing computer science, like studying it in high school or university, then I think you should definitely try competing in the USACO because it's a fun experience, especially in lower divisions like bronze and silver. And yeah, basically don't force yourself to do it if you're just not having fun, if you're just like not really having fun, if it feels like you're just kind of being forced to do it, because if that happens, then you're not really learning anything at all. Just start preparing whenever you feel prepared. And yeah, that's basically it.
Okay, so for today's wrap up, yeah, we would like Andy and me at the same perspective. That is, follow your heart and find your interest. And no push for yourself, even though your mom or your dad ask you to learn something. Yeah, just follow what your interest. Yeah, from. So our Bitcoin Club is the same. Yeah, we don't really teach kids computer programming. So we ask kids learning at the very beginning, like a K to grade 2, we teach them computer science without computer. We don't use computer to ask them to learn code. So it's just kind of fun. So we are right now we have a online offline class was located at the Cupertino. Right now we have 3 classes open on set, which is face-to-face learning. So if you would like to attend our offline class, and then you can join our Bitcoding Club location at the Cupertino side with the case. We have a kindergarten case to grade 2 case, and they learn computer science without computer. But we also have the older case, such as grade 5 to 8, and they learn computer how to build up a website to impact the world. So if you have any interest, just log on our website, like the screen showing. Yeah. All right. I saw Andy is kind of offline right now. Is still there? Okay. All right. I think it's pretty much all for today's presentation. If you don't have any questions, Andy. Okay.
Yeah.
And yeah, and that's all for today's presentation. And welcome to our Bitcoding Club website to look on our courses, activities. We have a lot of fun classes. Our fun club, we open a lot of fun club, yeah, which you can participate. All right, that's all for today. Thank you all for coming. And we do have another webinar for next week, the same time. Okay, thank you, Andy. Thank you all for attending today's webinar. Have a nice day. Bye.